Okay. So now what we have is this Hadoop 2.0. So now we will get introduced with the Hadoop 2.0 architecture, guys, and that's where we'll see that how we can overcome these challenges in terms of the architecture, current architecture what we have with Hadoop 1.0. How in Hadoop 2.0 these things will be taken care by enhancing this particular architecture. So whenever you talk about the Yarn or Hadoop 2.0 architecture, guys, it is very important that you understand the current existing architecture, and based on that, you will be able to relate how these things get improved with the new Hadoop 2.0 architecture. Okay, so when we are talking about the Hadoop 1.0 architecture, guys, we basically saw the challenge on the two places. One was on the storage side, where you had the Hadoop file system and you wanted to have basically a reliable storage on inside the system, and you wanted to have the scalability of the name node. So as you grow with the data node, you can similarly you can increase the name node main memory as well, so that you should be able to store more data inside the cluster. So that's where what you get in Hadoop 2.0 is basically you get the federation of the name node. So in Hadoop 1.0, what we had is we had one name node, so it will have the single namespace. What it means is, so if you have one machine that is acting as the name node, so whatever the RAM is available for the name node, so that's the namespace you have to store the metadata, right? In Hadoop 2.0, what you have is you have the multiple name nodes. So that's what you have, the multiple namespace. So what it means is, now you can have multiple name node inside the Hadoop cluster. And like if you have like 2 name node inside the Hadoop cluster or 3 name node inside the Hadoop cluster, so each of them can store like 64 GB of the data, right? So so that way you basically enhance. So tomorrow, if you hit a limit in terms of all these 3 name node machine, like whatever the data it can store, so in that case what you can do is you can add the 4th machine inside the cluster, and then it will have again 64 GB. So you can store more data inside the Hadoop cluster, and that will be managed by the 4th name node. So that's the kind of the architecture you are going to have with the new Hadoop 2.0 architecture, where you will have multiple name node instance that will be running inside the cluster. Okay, so that's the one major enhancement you have with the Hadoop 1.0 to Hadoop 2.0. Okay, so one thing was the federation, guys. So instead of having one name node and the single namespace, now you are going to have multiple name node and multiple namespace. Second thing is the availability of the system. So if you talk the Hadoop 1.0 architecture, what we have is whenever the name node goes down, so at that point you have only the concept of the secondary name node, but then the whole process of recovering that the name node with the help of the backup files created by the secondary name node, it's going to be a manual process. So now with the Hadoop 2.0 architecture, what you have is you have the automatic kind of the switchover in case of failure. So you have this the standby nodes which basically share the logs, and based on that sharing, if at one point if one of the instance of the name node goes down, the another instance of the name node will take over immediately. So you don't have any manual process to basically switch over from the failure name node, and that way you will see that it is like a highly available kind of a system that you will have inside the Hadoop cluster now. Okay. Then the third thing what you have is basically enhancement in terms of the processing. So in Hadoop 1.0, what we have is the job tracker and the task tracker that acts as basically a processing mechanism inside the Hadoop cluster. So now with the Yarn architecture, this part has been a bit simplified, and you have a little bit more terms in terms of managing the whole stuff. So now you have the concept of this resource manager, node manager, application master, and the capacity scheduler. So with the help of all these, what you do is you manage the Hadoop cluster in a much better way now in Hadoop 2.0. So we'll see in the flow like how these things interact with each other when it comes to the submitting the MapReduce job and executing with the Hadoop 2.0 architecture. But here let's quickly get introduced with these terms, guys. So resource manager is something like which controls the usage of the resources across the Hadoop cluster. So all it will do is it will see like what all the resources it's available inside the cluster and who is utilizing that. So all those things will be maintained by the resource manager. Then you have the concept of something called the node manager. So that's going to run on each of the data node that we are going to have in the cluster. So each of the data node, it's going to run something called the node manager. So instead of having your task tracker, what you have is now that node manager that's going to run. And it's going to basically create something called the execution container. And that will be basically executed on each of the worker machine or the slave machine which you have inside the cluster, right? Then the third thing what you have is basically the application master. So that basically coordinates and manage the, like whenever you submit now a MapReduce job, so that whole job stuff it will be managed with the help of the life cycle of that job will be managed with the help of the application master. So what this application master is going to do is it's going to basically work with the resource manager to schedule the task, to get the resources, and based on that it will take the help of the node manager to execute that particular task on each of the slave machines. So we'll see more detailed diagram of this one, guys, how the whole interaction works. Okay. So at this point, guys, let's see the new architecture, the Hadoop 2.0 architecture. So what you have in this particular architecture, as you can see here, guys, so on the left hand side you can see the Hadoop 1.0 architecture. So that will help you to visualize and relate how the things changes in Hadoop 1.0 to Hadoop 2.0. If you see the architecture in Hadoop 2.0, we had the single name node, and that's what it was maintaining all the blocks inside the cluster. And then we had the multiple data node that will basically distributing the load in terms of the storing the data. Now with the Hadoop 2.0 architecture, what we have, guys, is like you have the multiple name node now inside the cluster. So you have like one name node that maintains one set of the data, then you have another name node that maintains another set of the data inside the Hadoop cluster. So that way basically you are able to have the more namespace in terms of the name node main memory, and then you have set up the data nodes. That's where the actual data that gets stored. So with this particular stuff, what you are seeing here, you are basically able to scale the name node here, and you are basically overcome the limit which we have, like a single machine, whatever the maximum number of the RAM it can have. So that's the kind of the metadata that you are going to store. That's the maximum number of metadata that will store in the name node main memory, and that will indirectly limit you like how much data you can store inside the Hadoop cluster. So that's what we had with the current Hadoop 2.0 architecture, guys, where you have now the multiple name node, and that's basically take care of the storage. So now what you will have is like as you can see here, so different blocks of the data, it will be basically managed with the help of the multiple name node which you are going to have inside the cluster. So now once we understand about this the availability aspect of the federation aspect of the name node, now let's switch over to basically understand the availability of the Hadoop 2.0 architecture. Okay, so let's see about this Hadoop 2.0 architecture in terms of high availability, guys. So as you can see here, one thing is what we have in the Hadoop 2.0 is we are going to have the multiple name node, and a multiple name node going to manage the multiple namespace. So basically we are going to achieve the horizontal scalability by adding the more number of the name node inside the Hadoop cluster. So that's one part, and that's what we are clear. The second aspect we have is with the availability of the system. If you remember our the Hadoop 1.0 architecture, what you have is you have the name node that's running as the name node machine, and then in case if there is any failure or something, so in that case the name node goes down, and then you have the secondary name node that basically takes the backup of the metadata. You bring back that metadata, and then start that machine again as the name node kind of thing. In case of Hadoop 2.0, what you have the architecture is like you have the active standby node and you have the standby node. So what it means is, like, if at any point, if this machine goes down, you will have another machine that will take over immediately. So that way, what you are going to do is you are going to have this availability of your system is going to be very high, because it is having this particular kind of configuration where the recovery, it happens automatically. So you have this kind of the cluster, this kind of the architecture is not new, guys. With the Hadoop itself, you have with the normal Linux system or Windows system also, you have this kind of architecture where one of the machine goes down, other machine will immediately take over and start handling all this stuff. So how it does that is that does with the help of something called the shared edit log. So whatever kind of the operation the current name node is doing in terms of the update, delete, all those kind of the steps are going to be handled with the shared edit log. So the information will be available in that, and that is going to be shared between the active name node and the standby name node. So when whichever machine goes down, the other machine will take over immediately with the help of the shared edit log that is shared between that. So now, since you have this active and the standby kind of the mechanism in the Hadoop 2.0 architecture, so if you want to have the secondary name node, so that becomes an optional kind of thing. So if you want to have much more reliability, that okay, you have the active name node, then you have the standby name node. If there is any failure on the active name node, the standby name node will take over. But at that point, if there is any failure in the standby name node and you want to have a backup mechanism, you can have the secondary name node. So it becomes completely an optional kind of thing now to have the secondary name node with the Hadoop 2.0 architecture. But as per the framework, yes, you can have this also as part of the Hadoop, as part of the Hadoop architecture. Okay, so let's see some more concept, guys, and that's basically in terms of the processing. So these are the currently architecture changes we had with in terms of the storage. So that the HDFS part which we saw. Now what we are going to see is we are going to see in terms of the processing side how it's going to happen. Okay, so in terms of the processing, what it's going to do guys here is instead of having a job tracker and the task tracker to manage all the execution inside the Hadoop cluster, now what we have the concept of the resource manager and the node manager. So that's where the way how the jobs are getting executed now. And one more shift what we have with the Hadoop 1.0 architecture to Hadoop 2.0 architecture is basically managing the life cycle of the application. So if you talk about the Hadoop 1.0 architecture, so there whenever you submit a MapReduce job, once the job is submitted, it will be the responsibility of the job tracker to manage all the number of the map and the reduced tasks that we are running inside the cluster, and whether it fails or succeeds. So that's going to be basically managed with the help of the job tracker. Now, in case of Hadoop 2.0, you have that responsibility divided, and that will be basically the managing the life cycle of the application that is going to be done by the application master. And apart from the managing the life cycle of the application, what it's going to do is the application master. That's what we see here, the new concept here, the application master. So apart from that, what it's going to do is it's going to coordinate and manage. Like if you talk about the MapReduce job, so it's going to have its own the application master. So it's going to coordinate and manage the MapReduce job inside the Hadoop cluster. And to execute your MapReduce job, it's going to negotiate with the resource manager to get allocated the appropriate resources. And once those resources are allocated and the task is scheduled to run, what it's going to do is it is going to basically go back to that node manager, and then it is going to ask to execute that particular job on the data which is lying inside the Hadoop cluster, right? So that's the way how this the resource manager and the application master is going to work. So now the life cycle of the application, it will be managed by the application master. negotiation about the resources, how many number of the CPU you want, how much memory you want. So all those kind of the things is now going to be negotiated with the resource manager, and resource manager is nothing but simply it will have the visibility about all the available resources inside the cluster. So it is going to use that to decide whether it can go ahead and allocate a certain amount of the memory or CPU or not inside the Hadoop cluster, right? And then once that storage happen, it comes to something as the container. So what it happens in terms of the execution is, you take this container, give it to the node manager, which execute that, as well as it monitors slightly the kind of the usage pattern it has, and based on that, it will report it back to the resource manager about if it is like like if it is allocated just from the app manager, like kind of 1 GB of the memory, and it's using like for the join or something, it's using like 4 GB of memory. So that is going to be basically reported by the node manager to the resource manager. So at this point, if you want to understand about the container, so it's nothing but it's like whatever the allocation you have from the resource manager for the execution of the job, like how much CPU it can use, how much memory it can use, what's the priority. So based on that, only you are going to get the resources allocated. So all those stuff, it will be part of the container. So let's see about the the Hadoop 1.0 and 2.0 guys. So you had the name node, and what the name node it has is it has the manual recovery process in case of the failure, and that's where you have the secondary name node that reads the data from the edit logs and the image file, and then it play it back, and then based on the data you recover the name node. In case of Hadoop 2.0, it is automatic failover, and to do that, what you have is you have the concept of this active standby name node and the standby name node. So they basically both basically do a kind of automatic failover whenever one of the machine goes down. And then you have this the secondary name node, that's nothing but an optional kind of thing. So if you want to have the concept of secondary name node, you can have that as well, which will connect to the name node which you are acting, and then takes the metadata from that. Okay, so let's summarize this discussion, guys, what we had here. So in Hadoop 2.0, you have the concept of the active standby name node and the standby name node. Along with that, what you have the concept of, you can have the multiple name node inside the cluster. And then the secondary name node, it becomes the optional stuff. And then in terms of the processing, what you have is, you have the the concept of something called the resource manager and the node manager. So you can see the responsibility of the resource manager is to manage the resources or schedule the task, and once the task is scheduled, the whole execution is going to be done with the help of the node manager. And what it's going to have is, it's going to have this component that the container, which will contain all the necessary information about how to execute the job. And then you will have the application master that will be basically controlling the life cycle of this particular application. So that way, this get also more enhanced in terms of the high availability of the system. So in terms of the Hadoop ecosystem, guys, so you can see the changes here in the ecosystem now. So instead of having this Hadoop and then Hive, Pig, MapReduce, and HBase as like the layer here. So whatever you want to process inside the Hadoop, it used to be the MapReduce job, and then only you get the data from HDFS. Now, what you see in the new architecture, the YARN architecture, is that MapReduce framework is replaced by something called the YARN architecture. So that's what we discussed just now. So with the YARN architecture, it will be basically more suitable for the cluster, the resource management. So that's more optimized kind of the algorithms that you have, and that can manage the resources better inside the Hadoop cluster. And then once you have this the YARN architecture, on top of that you can run the MapReduce. So it always has the backward compatibility, guys. So whatever the application is there in Hadoop 1.0, it's still going to run in Hadoop 2.0 only in some cases. If it is using very old API, so then in that case you have to basically recompile that. Apart from that, all the MapReduce job is going to work on the YARN architecture as well. And then the high peak, everything is going to come now like this particular framework and it's going to be executed. Now, apart from the yarn, what else you have is like you have all these graph processing and all those stuff also now it's part of the Hadoop ecosystem. So you can run the other framework as well on top of Hadoop, and then you have the HBase as it is. So these are the stuff, guys, which is like available apart from the MapReduce. So if you remember our earlier discussion, so you are going to have the Hadoop file system. On top of that, you are going to run the yarn. So what the yarn is, guys, it is called as at another resource negotiator, right? So that's what the whole notion of the yarn is, at another resource negotiator. Okay, so it's basically a kind of a big enhancement in terms of how you manage the cluster. And the company, right, which is significantly contributed on this project is, guys, is the Hortonworks. So Hortonworks, the founder Arun Murthy. So they were the guys who basically separated and they started contributing this yarn architecture. And then last year we had this yarn as a full-fledged offering from a kind of in support and all from the Hadoop architecture. So other kind of application that you can process in this new architecture is, guys, you can do the batch processing, you can do some kind of the interactive querying, you can do some HBase kind of stuff. If you want to do any streaming or something, you can do a Storm and Spark, all those stuff you can do that. So this in-memory implementation where you can use Spark. You can do the graph processing. You can do basically any kind of the parallel processing you want, any kind of the other search implementation you want to implement. So all those kind of the applications now it's possible to run on top of the Hadoop with the yarn enable architecture. Okay, so now with the yarn architecture, since it is the yarn architecture is basically designed to have better cluster kind of better management of the cluster resources. So you have now the implementation of the job queue. So you can have the job queue that's basically going to put a hierarchy like how the jobs are going to be executed. So you can have the queue that will share the percentage of the cluster. Like if you have the priority number 1 job, so that will get like 80% of the resources. Then you have the second priority job that will get 10% resources. So all those kind of the resource management you can do with the yarn architecture now. Then you can implement this hierarchical queues. So you manage the resources within an organization. So whichever the top priority job that runs fast, and other jobs it runs with a less priority. Then you have better in terms of the capacity guarantee, because now you have the dedicated process that's called the resource manager. It keep looking all the available resources inside the cluster and it manages that. Then apart from that, you have this all these security and elasticity in terms of how the resources will be available, and it can be used in different queue. Then you can also enable now with the multi-tenancy. So instead of having just Hadoop dataset, or whatever the data you store in HDFS file system to get used by the MapReduce processing, now you will have multiple footprint in terms of the multiple different kind of the application that will read the data, right? And then you will have all these the resource-based scheduling. So whenever the application need more resource, it is going to negotiate with the resource manager, get the necessary resource, and then do the execution. Having another discussion, guys, that will basically tell you how when you submit now a MapReduce job inside the Hadoop cluster, how the whole execution of the MapReduce works inside the Hadoop cluster, right? So let me explain you the flow, and then we'll see with the diagram like how the whole stuff looks like. Okay. So what you have with this the new flow which we have. So in the new flow, what you do is you submit your job. So that's basically the client. You will submit your MapReduce job. So once you submit your MapReduce job, what will happen in case of the Hadoop? I will show you with the flow, guys, how it works. So when you submit your job, so basically it gets job ID and all those stuff. Once that part is done, it is start in terms of the execution of that particular job. And that's where this MapReduce application master is going to come in picture. So now suppose if you submit a MapReduce job, so it will be the MapReduce application master responsibility to negotiate about the kind of the resources that you will use for the program. So like suppose in your program, if you are using a kind of a join, and you have specified certain settings related to join, how much memory you need and all those stuff. So it will take all those things in consideration, and like how much resources will be needed to successfully complete the job, and it will coordinate and manage this activity of this MapReduce job execution with the help of something called the resource manager. So it is going to contact the resource manager to negotiate about the resource manager to basically schedule the task. So it has to get the container in terms of like which CPU it has to be used, which machine it should be executing that particular processing. So all those information it is going to negotiate with the help of the resource manager. Once that is done, what the resource its name node is going to do is it's going to take that allocation and bring back that allocation to the node manager. So it will be the responsibility of the node manager to execute that task. So now the application master will start communicating with the node manager. So what the node manager does is it will run on each data node. So how you had the task tracker that was running on each data node. So similar way you have now the new process. So you can remember this name, guys. So now you have the node manager that will be running on each machine inside the cluster, and it will basically it will take the container which is provided by the resource manager. Sorry, by the application master, which is negotiated with the resource manager, and it will be given to the node manager to execute that. So node manager will basically create an execution container, and then it will monitor how the the container uses progress. And to do all these operations, guys, whatever the data you need or any other artifacts for the data, like any configuration file, anything, everything is connected with the SDFS. So that can be used by the node manager whenever it's executing the job, and it can read the data set. So that's the way how the whole flow is going to work in terms of the MapReduce processing inside the cluster. So you have the client which will submit the job. You have the application master that will take the ownership of execution of the job. It will coordinate and manage the MapReduce job. So it will negotiate the resources with the resource manager. Once that is done, it will take that to the node manager. Node manager will run that each task, and once that is done, it is basically going to report it back that the task completed, or if there was any failure. And all these things, for the data and all, it's going to read that data from the HDFS file system itself. Okay, so now we are going to basically see it in more graphical way how the things looks like with the yarn architecture. Okay, so what we have here is like the client submit the job, and then you have the resource manager that is going to basically allocate the resources based on the request coming from the application master. So once the application master see a MapReduce job, so it's going to negotiate with the resource manager in terms of having the the available resources. And once those resources are allocated, it will be allocated in form of the container. So it will take that container and it will go to the node manager, and then node manager will execute that container, and based on that it will report it back about like how the the job succeed or failure kind of thing. So in case of resource manager, it is like more like a cluster level resource manager. So it manages all the resources that we have in the cluster. Very long life, high quality of the hardware. So basically you are going to run this on a kind of admin kind of machine where you will have this resource manager running. Node manager, it is going to run on each data node. So that's what you have the node manager, and it monitors the resources on the data node. So it's going to execute the container, as well as it is going to maintain the basically the resource used in each of the data node. Application master, it's going to be the one per application. So like MapReduce will have its own, big hive it will have its own. So like that way it's going to have, and it's going to have basically whenever you submit a particular kind of the job, this application master will come in picture, and then it will start the managing the life cycle of your all the processing inside your application. Okay, so this is like more detailed description, guys. I think that will add you to more clarity how the stuff works here. So what you have here is you have the your application that will submit the job. So once you submit the job, what it happens is it gets submitted to the the master node which you have, and it gets a job ID kind of thing. So based on that, your whole execution will start. And what the execution happens here in this case is basically based on the kind of the job you are submitting. Like if you are submitting Hadoop MapReduce job, so it know that the MapReduce application master. So it will take that, the application master will come in picture, and then it will start seeing like whatever the details you have provided for executing the job, and based on that it will start working with the resource manager to get allocated the necessary resources for your the request. And based on that, then the availability of the resources, the node manager is the resource manager is going to allocate that particular container. So it will basically have this container that will get created. Then application master will bring this container to the node manager, and node manager will basically start executing this particular container which is provided by the application master after negotiation with the resource manager. Once that part is done, we will have basically a kind of yarn child process that will get created, and that will run the MapReduce task. So that's the way the execution happens with the MapReduce application, where your application master coordinates with the resource manager, get the resources, get the the kind of the CPU memory it wants to run, and then come to the node manager, submit it to the node manager, execute that task, and then basically store the data back inside the Hadoop file system. Same stuff, guys. So all you can see here is it's like once the application is done, the container get executed, it will store the data back inside the HDFS, and that's where you will return back to the job object about the the status of the job. So it will be the responsive application master to respond back to the client in terms of the status of the job, like failure, success, all those stuff. Right. So if you summarize this whole workflow, guys, so this is the way how the whole workflow is going to run. Yeah. So you have again the architecture. It remains like the master and the slave architecture. Only thing in terms of the processing, you call it something called the resource manager and the node manager and the application master. So based on your allocation from the resource manager about the container, the application master is going to bring that to the node manager, and node manager is going to execute that particular container based on the availability of the the data set. It is going to execute each of the container on the machine where the node manager is installed. Step 2 does, guys, is it's basically whenever you submit a job, it registers itself as a new job, so it gets new application ID, and then it will be like basically based on what kind of the job you submit. Those the application master will come in picture. They will start negotiating about the resources with the resource manager. So once that resources are allocated by the resource manager, so what it will do is it will bring that resources back to the node manager, and that's where the node manager will basically create a container and start executing that container. So for that, what it does is it basically creates a yarn child process, and that's where it will run the MapReduce task. And to run this MapReduce task, at any point if it needs the data, it will get it from the Hadoop file system and will give it to the yarn process. Right. So that's the kind of the execution which we are talking about here with the yarn architecture.